Hello everyone, we are Team 3 of Section 15 and today we will present our findings and accomplishments during the robotics portion of the ME 435 course. This video will cover Labs 1 through 3 as well as our final project. During Lab 1, we were tasked with simulating the Dobot in MATLAB. We were able to successfully do this by creating rigid bodies within MATLAB that acted as a robot segments and connecting them together with joints. This allowed the robot to move much like it would in real life. We also implemented forward kinematics, which allowed us to input how the robot will move from point to point. This was a more manual part of the coding, as the robot had to be told exactly how much each motor should move. We also utilized reverse kinematics, in which we told the robot where it should go, and it did the calculations itself to move to that position. If the location of the endpoint was known, the robot could automatically get to the position. Also in Lab 1, we learned the basics of how to work with the Dobot software and the robot itself. One of the main components we got very comfortable with was the move commands and the difference between move J, move L, and jump. Move J allows each joint to move independently while in translation. Move L moves the robot arm linearly to the next position, and jump uses movements only in one coordinate direction at a time. One of the software components we learned was how to create a flow. This is represented as a course of actions that the robot must take, much like a code for programming software. Flows are a form of graphical coding so that it is easier to conceptualize and work with. With this, we had learned the basics of Dobot and were ready to move on to the next lab. For Lab 2, we stepped the complexity of our robot's movements up by a lot, this time by incorporating a conveyor belt with an IR sensor. Our team was tasked to learn how to set up flows so that when a colored block was in front of the IR sensor, the conveyor belt would stop and wait until the block was removed. For the software portion, we also learned a couple of new commands such as using branches. This allowed the flow to be separated into multiple subflows. This command was useful when the robot was waiting for input from the IR sensor and waiting until there was an input and switching the other flow when the IR was triggered. This allowed us to perform a task for the robot to pick up a colored block from the conveyor belt every time it reached the IR sensor and place it somewhere else. In the final portion of the lab, we used the camera connected to the Dobot to recognize images. Our team was able to use the camera to take a picture, recognize the image it was looking for, and find the distance between multiples of the same object. With the camera now in our tool belt, we were able to go on to the next lab. Lab 3 introduced us to communication between robots. We were able to wire up a breadboard with two Dobots and have them communicate to one another. With this new form of communication, we were able to pick up a colored block that was placed by another team and transport it somewhere else. Once the setting team was done with placing the block, our robot was triggered to begin the flow. This is what allowed us to complete the task successfully without crashing our robots together. The second portion of the lab required us to pick up rectangles and place them into a frame with empty places for the rectangles. This portion of the lab required a lot more software manipulation than the last task. First, the Dobot must be calibrated for that configuration, which would affect if the measurements of the camera's X and Y would match up with X and Y of that of the Dobot that was programmed to. The Dobot would take a picture of the surface and identify the pieces of interest. Once the pieces were identified, the robot would move to the middle position above the rectangle and pick it up. During the first picture, the robot would also determine where to place the rectangles. Because the rectangles were crooked and the slots were vertical, we had to make use of the shell module command. This command allowed us to create variables that would characterize the angle of the pieces with respect to the correct angle. Then, with a second shell module, we'd be able to take that angle of the original cutout and match them with the rectangle's angle. This would allow the robot to rotate the pieces with a proper position and place them into the cutouts. Now, with all these tools together, our team was able to finally tackle the final project efficiently. For the final project, our team was tasked with sending the correct colored letters to the other team, as well as receiving letters and placing them into the correct puzzle piece. For the sending portion of the task, we determined that the main components of the flow were going to be to distinguish which letters were of interest and transferring only those. This flow used a lot of components from Lab 2. We used the colored components of the camera to take RGB pictures, then use a color extract as well as a fast match to only pull the color and letter we wanted from the pile of letters. This allowed for the Dobot to assign positions to the colors of interest. With this extraction complete, the robot was able to calculate where the position of the letters were and pick them up to send to the other team. We also used an I/O sensor to determine when our robot was supposed to begin their movements. To avoid collision, our team linked up with the other team's robot so that once they had completed their movement of placing the piece into the puzzle, our robot would be triggered to deliver the next piece over. Moving on to the receiving portion. This portion took a lot from the lining portion of Lab 3. Once we received the part, the robot would take a picture and figure out which letter it would see and move the piece into the puzzle in the correct orientation. For our flow, we used a branch in our system to bypass any confusion of the robot. Many times, the robot would confuse letters together and put them in the wrong places, but by placing a branch, the robot was able to go from one letter to the other and match more correctly. This allowed for the robot to accurately match the projected letters onto the actual letters because it had a wider database to go off of and pick which one had the most points that would line up. This would take care of the fast match portion of the flow, while the shell module would be responsible for the tuning of the actual letter and turning it into its correct position. Much like Lab 3, the robot would use the shell module to match the angle of the puzzle with the angle of the piece and move it accordingly. We were able to take the original flow from one letter and copy it 2 times over, which acted as the individual flows for the rest of the letters. With this, our team was able to correctly slot in all the puzzle pieces with very little error in the calibration of the placement. We hope you found this video as enjoyable as we did these labs. Thanks for watching!